Okay, we're looking at second year Stats and Mechanics textbook, and we're on exercise 4E. So chapter 4 is on moments, and 4E is focusing on tilting. So looking at question 2, so we've got a uniform bar, so that means that the centre of mass will be the halfway along the bar. Careful here, I'm given its actual weight rather than its mass. So I don't need to multiply that by G. The weight is 40 newtons. And it's on two supports at C and D. So let's get that sketched out. Okay, so there's my rod and my uniform bar AB. The whole thing is 6 meters long, and AC is 2, and AD is 5, so not drawn to scale, but something like that. Let's label on the weight of the rod. So that's going to be, that 40 newtons is going to be working halfway along the rod. So that's going to be between C and D. It's not quite as symmetrical as my sketch looks, but I think I'll get away with it. Okay, so that is a weight of 40 newtons, not a mass of 40 kilograms. So careful there. Then we are, right, so we're then attaching a weight, and they're not telling us where we're attaching it. So that's what we're going to work out. So I'll leave it a second before I label where I think E is going to be. Okay, and it's when you stick E on, it's going to tilt about C. So this is sort of the idea of this exercise, this idea of tilting. So if it's going to tilt about C, what that's saying is it's going to be pivoting at C, and it's going to start tilting. So obviously D is going to be getting in the way, so this end can't come down. So it must be that end A is going to come down and then B is going to come up. Okay, so if it's tilting, or if it's about to tilt, there will be a reaction force at C, but there won't be a reaction at D. So hopefully you've had a read through this chapter. And that's the whole idea. So basically, if it's about to tilt, it means this end of the bar is about to raise up. So although it is still just touching at D, there is no force there. It's just on the cusp of lifting up. So there's no reaction at D. Okay, so now if we think about where E is likely to be, where E has to be, well, if that's going to happen, if it's going to tilt about C, there must be a weight pulling down here. Okay. So I don't really need to worry about getting that to scale. So there's E, and that's a 30 Newton force. Okay, if I had that in the wrong position, it should still work out. It's just I'd end up with some negative lengths and it will get a little bit confusing. Right, okay, so I do know R. If I just resolve vertically, I can say that R is 70 newtons. Okay, but to be honest, I don't think I really need that. I don't think I'm going to use that because I think I'm going to take moments about C. You don't have to do that. You could take moments about A because that's where we want the length from. Okay, but I think I'm going to take moments about C because if I take moments about C, we don't need to include the reaction at C. So that if I'm taking moments about C, I only need to worry about this force and this force. Okay, so if I'm going to take moments, I'm going to need some lengths. So I don't know this one, so I'm going to call that X. That's the whole point of the question. I think I should be able to figure out this one though. So it told me in the original question that it was a uniform rod. So I know that the 40 newtons is working halfway along the rod. So that is going to be 3 meters from A. And I know that C is 2 meters from A. So that must mean that that's 1 meter. And this is literally just the difference between those. Okay, and I think that's all I need to worry about. So I'm going to take moments about C. So I've got this force is going to be pulling the left-hand side down. So that's going to be turning the whole thing anti-clockwise. So that's going to be a force of 30 newtons multiplied by a distance of X meters from C. And that's the only anti-clockwise moment. So that must equal this 40 Newton force, which is going to be putting the right-hand side down. So going to be trying to turn the whole thing in clockwise. and that is 1 metre from C. So 30x is 40, so x is 40 over 30, so 1.33 metres. Okay, so it doesn't look like that in my diagram, but that is a reasonable answer because that was right, I must make sure I actually answer the question. So that was 2 metres, so obviously if that had been more than 2 metres, I'd have had a problem. But yeah, be really, really careful because my x is not the actual distance I wanted. So my x is the distance from E to C. So that's not a problem at all, as long as I don't forget that. So I know that is 2, I'm not quite sure how I do that, right. So I know that is 2 metres. That's the distance I want. So AE is actually going to be 2 metres minus my value for x. So I'll stick to 3 significant figures, or I could give that as an exact value. Okay, so let's just double check that answer. Yeah, 2/3. We gave it as an answer to 3 significant figures.